Okay, let's continue where we left off with this one. And don't forget, NIDA always has help down here, and it's actually showing you how they converted the 30 microfarads down to farads, basically divided by 1 million. So if you didn't understand that, and you didn't know why, NIDA is actually offering you an opportunity to understand that. So let's move on. All right, so we got our first one here. And again, with NIDA, always be careful to look at the question, because a lot of people will automatically assume that we're asking overall capacitive reactance, which would mean doing the formula for these two and then running the X of C formula, the 2 pi F of, FC over 1. But here it's asking only for C1. So we got to make absolutely sure we get that, and we're not doing what we don't need to be doing to arrive at the incorrect answer. And that is pretty good about sometimes giving us the right answer for the total if we do that. So always be sure of which one you're doing here. So we know the formula is 1 over 2 times pi. I'm using my mouse and it's a little more painful for this, so I'll switch back to the pen here in a minute. FC. So we got that formula right here in front of us, so basically it's just a matter of filling in the blanks. Now remember, we're going to have to do the math on this capacitance because our frequency is in hertz. So we'll have to make sure we do some conversions. So 2 times pi, which we know is 3.14. Frequency is 500. So we'll put a dot there to remind us to multiply that. And then we're going to have to take this 30 microfarads and divide it by 1 million. And it's really, really easy to confuse units here. So I'm just going to say 30 divided by 1, 2, 3, 4, 5, 6, 1 million. And we have 1, 2, 3, 4, and then 3 zeros. So have to make sure we apply that accordingly. So this is just a placeholder 0. 1, 2, 3, 4, and then our 3. So that's our math right here. 2 times pi times 500 times 0.00003. So again, I've got this 1 over x. I can reciprocal formula, reciprocal button on my calculator. So all I have to do is the bottom and then invert it. So 2 times 3.14 times 500 times 0.1234 equals, and then get the inverse of that, 10.61 ohms. And sure enough, that is an answer right here before us. So let's click on that, and there we go. So let's clear this out, and we're probably about to do the other one. Yep, sure enough. So let's clear out our calculator here. And again, let's apply the formula. And these formulas, you need to write them down. And once we get into the more complex stuff, it's simply just a matter of understanding what we're doing and applying the formulas. So 2 pi FC. And again, we're going to have to use that conversion on the capacitance side. But we should know it now because we just did 30 and 60 is going to be the same thing, just with 6 instead of 3. So 2 pi 500. Let me stick in our little times. I don't like that. Let's see if we can do it. Oops. So 2 pi times 500 times 0. Remember, it's 4, 1, 2, 3, 4, and then 6. So all the difference is it's C2 now up here, C2. So we'll come down here, we'll bring our calculator into the picture, and we'll make this one happen. Should be able to figure it out almost from what we had before, but let's do the math. So 2 times 3.14 0.14, which is pi, times 500 times 0.00006 equals, invert that, 53.07. Oops, I dropped the decimal somewhere. Let's try that one more time. Something's not adding up. Should be 5.3 because it's half of the 10.6. 2 times 3.14 times 500 times 0.12346 equals, invert that, 5.3. So yeah, obviously I just messed up and added a 0 somewhere or left off a 0 somewhere, which is very easy to do when you're dealing with this many zeros. But anyway, 5.3 is our right answer, and sure enough, there it is. So note, X of C of a 30 microfarad capacitor at 100 hertz is 53 ohms, and at 500 hertz is 10.6. As frequency increases, X of C decreases. So our capacitive reactance decreases as we change higher frequencies. And all they did here, in case you're wondering, is they did the formulas with one, oops, the mode is not on, but we'll fix that. And let's switch a different color. This black doesn't always show up well on the blue. Let's try this. Okay. So it's 1 over 2 pi 100 times 30. So we did that for here. We did 1 over 2 pi 500 times 30. So everything's the same other than our frequency went up. And here's what happened. The X of C here is 53 ohms. The X of C here is 10.6. And it's relational. If we divide that by 5, we come down to 10.6. So frequency rose by a factor of 5. X of C dropped by a factor of 5. So we see those are proportional, inversely proportional as far as the X of C goes, and we can see the relationship there math-wise too. So hopefully that helps you understand some of this. So let's move forward, and let's change to our mouse, shall we? Here we go. All right, and if we change to look at the difference between the values here. If we say at 500 hertz, and we change from a 30 to a 60, our X of C also drops. The higher the capacitance, the lower the X of C. So they are inversely proportional as well. So as we go up in capacitance, we're going to go down in our X of C. So in a series circuit, total capacitive reactance is calculated like total resistance. We can get, in a resistive circuit, we can add the two resistors. In a capacitive circuit, we add the two impedances, the X of C1 and the X of C2, and get total capacitive reactance there. So do it just like we do resistors. And just add them together as it's saying. Showing you here 10.6 plus 5.3 gives us 15.9. And or we can go ahead and get the total capacitance. If we go ahead and get the total capacitance of 20 microfarads, for instance, because remember, and I told you this was going to be a step-by-step thing here at some point, and that's exactly what we're doing, is we're doing some step-by-step calculations. With the 30 and 60, we're doing product over sum. So we're getting, we're basically taking 30 times 60 over 30 plus 60. And that gives us 1800 over 90. If we do the math there, that equals 20. So that gives us this 20 microfarads that we see right here that they calculated. And then we use that 20 in the formula of 1 over 2 pi times 500 times, and remember this is 20 microfarads, and so we have to divide 20 by a million. Don't be afraid to use that calculator and get that right, because you saw what one decimal will do to us. 20 divided by 1 million, and that is 4 zeros and then a 2. So over here we have to say 0, and I like to use that leading 0, which is just a placeholder, but we don't count it when we put it in the formula. 0.00002. So these are times, and I know I use the dot sometimes. It's probably better to use the X. So let's break out the calculator here and do this one, shall we? So if we say 2 times pi, 3.14, oops, back that up, make that a 4, probably wouldn't have made much difference, but we want to be right, times 500 times 0.12342 equals, and reciprocate that, we get 15.9, which is the same thing they got applying that same formula. So we came out with the same answer. We could have done each one of those individually, which we did in the first couple of problems, at the 10.6 and the 5.3, added them together. Or we can go ahead and get total capacitance, apply that to the capacitive reactance formula, and get that as well. So it's 6 one, half a dozen other, kind of whatever floats your boat, so to speak. But if you're going to be solving a circuit, it's probably better to get the individuals if you'll end up having to deal with currents and things like that. But that's totally up to you. And if you have to go back and do it a second time, that's fine as well. So in a circuit containing capacitors only, we use Ohm's law to solve for the other circuit values. X of C replaces the R in Ohm's law. So right here, X of CT, the 10.3 plus 5.6 gave us 15.9 right here that we're looking at right there. And if we take 100 volts, divide it by 15.9, we get 6.29 amps. So let's see that on the calculator. So we're basically using Ohm's law. Let's get rid of this writing over here. We're basically using Ohm's law. We're taking that 100 volts and we're dividing it by the 15.9 ohms impedance. And that gives us 6.29 amps if we round up. So now we've got 6.29 amps of effective current running through here. And we can take and calculate the voltage just by multiplying the capacitive reactance of each one of these times the amps. So for instance, this one was, let's see, our 30 microfarad. Let's go back and make sure I say it right. Our 30 microfarad was 10.6 ohms. So remember, voltage is I times R. So 30 times 6.29 amps times R. Oh, excuse me, not 30 times 6.29, but rather 10.6 times 6.29. I knew that didn't sound right. So I being 6.29 amps times R being 10.6. 10.6 gives us an effective voltage drop of 6.674. And that's what they've got here. And if we did the same thing over here, I 6.29 amps times, remember this was 5.3, comes up with 33.337. So that's where they're getting their numbers. So it's basically Ohm's law, and we're going to be moving forward in the next video with this. So as always, if you have questions, we'll resume in the next video.